So let's now talk about stemming and lemmatization. Now, for grammatical reasons, documents are going to use different forms of a word. For example, join, you might see joins, joining, or organize, organizes, organizing. Additionally, there are families of derivationally related words with similar meanings, such as democracy, democratic, democratization. In many situations, it seems as if it would be useful for a search for one of these words to return documents that contain another word in the set. So when we talk about stemming, we're referring to a crude heuristic process that chops off the ends of words in the hope of achieving this goal correctly most of the time. And often it includes the removal of derivational affixes. So removing affixes from words and returning the root word. For example, the stem of the word working is work. So that is what we talk about when we talk about stemming. How about lemmatization? Well, this refers to doing things properly with the use of a vocabulary and morphological analysis of words, normally aiming to remove inflectional endings only and to return the base or dictionary form of a word, which is known as the lemma. If confronted with the token saw, stemming might return just the S in SAW, whereas lemmatization would attempt to return either see or saw, depending on whether the use of the token was as a verb or a noun. The two may also differ in that stemming most commonly collapses derivationally related words, whereas lemmatization commonly only collapses the different inflectional forms of a lemma. The goal of both stemming and lemmatization is to reduce inflectional forms and sometimes derivationally related forms of a word to a common base form. As we can understand, both techniques could remove important information, but also help us normalize our corpus, although lemmatization is the one that is usually applied. Now, there are many algorithms for stemming, and most of them produce similar results. And here's just a look at the different embedded stemming algorithms in an LTK. But the most used algorithm is Porter stemming algorithm. So let's try this one then. We're just going to type from nltk.stem import Porter stemmer. Stemmer equals Porter stemmer, open and closing parentheses, and then we'll do print, opening parentheses, stemmer.stem, and then in parentheses running with apostrophes around running. And we'll do two parentheses to close that out. And then again, print, opening parentheses, stemmer.stem, and then in parentheses decreases. And then finally print, we'll do the same thing, but this time we'll type in multiplying. So let's see what we get. And there's our output. So let's try now the same with the Lancaster stemming algorithm. So we'll do from nltk.stem and then import Lancaster stemmer. And then we'll do basically the same thing as we did above. So I'm actually just going to copy and paste the rest here, all the print portions of it. And then we'll run that. And this is what you get. And now let's try with the snowball stemming algorithm. So we'll do from nltk.stem, import snowball stemmer, and then stemmer equals snowball stemmer, and then we'll pass English here with double quotation marks around it. And the difference here is that we need to specify the language to initiate this particular stemmer. And then again, the rest we'll just copy and paste up here. And now we'll try another one here. We're going to try one called the WordNet Lemmatizer algorithm. So we're going to type in from nltk.stem import WordNet Lemmatizer. And then next line, Lemmatizer equals WordNet Lemmatizer, opening and closing parentheses. And then we'll type in print, opening parentheses, Lemmatizer dot lemmatize, and then in parentheses with apostrophes around, we'll do running. And the next two lines are the same, except of course what's in the parentheses. We're going to put in decreases in the second print and then multiplying in the last one. And here's what we get here. So stemming works on words without knowing its context, and that's why stemming has lower accuracy and why it's faster than lemmatization. Now we can also specify the part of speech in lemmatization, and we're going to talk about part of speech tagging in the next video.